All right. Welcome to the Denver, Erlang, and Elixir Meetup. This is for April 3rd, 2023, if you're tuning in on YouTube. Very briefly, this meetup is sponsored by Praxeal.io, which is a security platform for Elixir and Phoenix. So here are the few of the use cases, but if you're using Elixir in production, please give us a look and consider us for your work. So the main event, big thank you to Sean for coming out tonight. He's speaking about building a conversational support bot with Elixir and Bumblebee. So I will stop my sharing now, and we're going to go over to Sean.
Awesome. Okay, so let me get my screen shared here.
Nice, looks good.
I don't think this is, yeah, good. Okay, awesome. So thanks everyone for coming out. I appreciate the large turnout and the number of people requesting for me to record this or for Michael to record this. I apologize to everyone that went, to the last month's meetup. I unfortunately was under the weather, but I know the talk that happened last month was great in my stead. So I actually a little under the weather tonight as well, but I figure I would just power through. So I got to stop scheduling the Denver meetups because I guess I get sick every single time the talk date comes around. The title of this talk is Building a Conversational Support Bot with Elixir, NX, and Bumblebee. I have to caveat this by saying that I wrote this talk like 2 months ago, or a little over a month ago, which apparently in the world of artificial intelligence and large language models is like a lifetime. So a lot of the material I prepared is like pre-GPT-4 and pre-getting completely obsoleted by all of the new AI startups that are out there. But I still think it's an exciting case study nonetheless of some of the powerful things you can do with Elixir and machine learning as well. Before we start, I have to caveat this by saying that the views expressed here are my own. They're not any of the United States government, the Department of Defense, or Army Cyber. Before we start, a little bit about me. So I am the author of Genetic Algorithms in Elixir, the co-creator of Axon, or the creator of Axon, co-creator of NX and the XLA. So for those of you that don't know, the book Genetic Algorithms in Elixir is kind of what kicked off the development of NX and the XLA. And I've been working on those projects now for, I think what's coming up on 2-ish years now. And it's been pretty awesome. I like to say I'm a machine learning enthusiast. I really just like to do a bunch of random machine learning things. In Elixir, I like to learn new things. I like to experiment. And I'm pretty excited with how this ecosystem has turned out. It's really awesome to see the amount of people that have gotten behind machine learning and Elixir and that are excited about having an outlet to do machine learning that's not Python or Julia or some of the other traditional stacks. Now into the content of the talk. So to preface all of this started when I got in contact with a company called Teller. So Teller is a company that connects users to, or connects your users' bank accounts to your application. And so Dan, Teller's CTO, got to talk to me about what the best open source alternative to ChatGPT was. So at the time, ChatGPT was all the rage, and he was interested in building something to do support tasks or to automate support tasks for the company. So in the case of Teller, it's a relatively small company, and taking engineers off of engineering time to handle customer support tasks is relatively time consuming. So we wanted to see if there was a way we could maybe automate some of those support tasks. So we came up with this idea of doing this with Elixir and Bumblebee. And the idea was we'd have a conversational support bot that would answer questions about the company, route requests to the correct individual. So for example, if there's someone has a question about the API, it's going to go to an engineer if the bot can't answer it. Or if someone has a question about billing, it's going to go to someone in operations. Really, we just wanted to build something that was the intelligent back end of the company and that could answer questions when engineers or other people in the company were not necessarily available. Some of the other things we considered was having the large language model interact with tools, and I'll talk a little bit about that later on, as well as having someone that can respond to both internal and external queries. So one of the things about having a support bot like this is you can use it to interact with people that are just onboarding with the company. So if someone has a question that maybe they have to wait for an engineer or someone else in the company to answer, through the mentorship process and their onboarding process, it might be a lot quicker to have a bot respond to some of the common questions you might have about the company. So that was our sort of ambitious goal. And I think we did pretty well in achieving a lot of it. There's still a lot of work to do. And it's, like I said, it's a little it's up in the air right now whether it's not, or whether it's worth pursuing this further with all the rapid advancements in large language models over the last 2 months. But like I said, it's an interesting case study nonetheless. So this is where the idea of Heath came in. So the bot's name is Heath, named after Heath Ledger, who is the greatest supporting actor of all time in The Dark Knight. No disputing that, obviously. And it's actually a Slack integration written with Elixir, Bumblebee, and XVice, and I'll talk about those libraries a little bit later on. The idea is that you have this bot in the Teller Slack, and you ask him a question, and then he responds with whatever the correct answer to that question is. Heath also records queries for further labeling and training. So one of the things in machine learning that's especially important is continuous training, continuous improvement. And so as Heath collects more data points, Heath gets better at answering questions about the company. So this begs the question, why Heath when there's OpenAI? I feel like I kind of have to address this because there are a lot of paid alternatives to solving the support problem. And honestly, that is a good question. It's something that's really worth considering. It's something we're even battling with a little bit right now. There are some drawbacks to using the ChatGPT and GPT or Anthropic or some of the other APIs out there. One big one is data usage and privacy. So depending on what kind of data you're sending to OpenAI, you might not want, you don't want them to have access to everything. And I think they did recently update their data usage policy to where they age off data after 30 days, or they are not using your data to improve their models anymore. But in some cases, it's actually not necessarily worth sending your sensitive data off to an external API. There's also the consideration of inference time and cost. So if you're able to host a model or fine-tune or specialize a model that's significantly smaller than GPT-3, then you can do much better in terms of inference time as well as costs. The ChatGPT API is pretty fast and also pretty cheap. So at the same time, it's a bit of a trade-off. And then another thing is fine-tuning models, large language models for specific tasks is expensive. So there are a lot of APIs out there that give you an interface to fine-tune the OpenAI a version of GPT-3 on your own data. The problem is that's extremely expensive, and you kind of run the risk of the model that you fine-tuned getting obsoleted when the next best large language model comes out. So this happened with a lot of companies in GPT-4. They have these specialized variants of large language models that are trained specifically on their data, so whether it be financial data or their code base or whatever. But GPT-4 was significantly better than these specialized models in zero and few shot scenarios. So what that means is that you can provide just a few examples to GPT-4, and in some cases you don't have to provide any examples to GPT-4, and it can just answer the question. So with how fast things are moving, you do kind of run the risk of getting or falling behind when the next iteration of large language models comes out. So, it is kind of a trade-off between choosing to run something on your own or to marry yourself to an API. My opinion of it is that you should probably just design your infrastructure to be pluggable. And actually, in this case, the Heath framework that we build is pretty pluggable or pretty capable of being plugged in with any large language model. So yeah, the first approach we used to build Heath was actually I'll call it a simple zero-shot approach. So if you've ever worked in, I guess, customer support, or you've interacted with, I'm sure everyone has a story of interacting with like a customer support bot on like a travel website or something. And you're answering one of like, they have a pre-canned set of responses for you to reply to whatever their queries are. And so that's kind of the approach we took initially. Was you realize that most of the support questions that get asked are variants of the same exact questions. So one thing that we can do is we can actually use a zero-shot classification technique in Bumblebee, and then classify a question as one of many frequently asked questions to the Teller API or to the Teller support channels. And then we can choose a canned response to that FAQ and then send that answer off. And it's a relatively simple approach, and it's quick to get that off the ground using Elixir and Bumblebee. So now as a quick aside, what is Bumblebee? I'm not sure, I guess show of hands, how many people have used Bumblebee or have at least heard of Bumblebee. I'm assuming if you're watching this talk, probably plenty. Yeah. So Bumblebee is a new library for doing machine learning in Elixir. It's kind of like the Transformers library that Hugging Face has. So if you've used Transformers has a large number of pre-trained models, open source models, as well as a set of pre-canned pipelines, basically, where you can do common machine learning tasks like text classification, named entity recognition, We recently just added like the whisper serving, so you can do speech to text and some other pretty cool things. If you've been following the development of the NX ecosystem for the last two-ish years, Bumblebee significantly lowers the barrier to entry. So when we first released NX, it's kind of the level of expertise required to get working with NX is up here. And then, Axon brings that down to here with deep learning, and then Bumblebee just, significantly lowers the barrier to entry for doing common machine learning tasks. You don't really need to do any machine learning to use Bumblebee. It's really just a matter of loading a model, loading a machine learning pipeline, and then call and predict. So our first attempt was implementing a zero-shot classifier using Bumblebee. What zero-shot classification is I essentially take a set of natural language queries, and then I give a model those queries along with labels that the model's never seen. So what this means is that I'm not actually spending any time training a model for these frequently asked questions. I'm not collecting a set of questions and pairing them specifically to one of my set of FAQs and then training this model with Axon or something else. I literally just have a model that's been trained on a large number or a ton of text, and then it's capable of classifying or attaching a label to that text without actually having seen any examples. So it makes it really useful to get something off the ground quickly. And as you'll see here, it's actually relatively simple to implement in Bumblebee. This is an example of how the zero-shot classification works in practice. So it's a natural language inference task where I have a premise and I pair that with a hypothesis. So in this case, my premise is I want to go to France, and then I build a set of pairs of hypotheses with that premise. So in this case, I want to go to France, and my labels are cooking, dancing, and traveling. So my premise, I want to go to France. This example is about cooking, and I predict the probability that that pair is correct, or that hypothesis is correct, given the premise. And when you do this for all of the labels in your data set, and then you normalize across all of those probabilities, you end up with a set of class probabilities that give you what the most probable label is for this task. And it actually does relatively well when you have models that are trained on a lot of text for broad use cases. You get models that perform pretty well, but there are some drawbacks that we'll talk about, and we ended up choosing a different approach. But this was really the first iteration of Heath. And this is an example of what the actual FAQ model in Heath Heath looks like. I have a ask function where I give it an input, which in this case would be a question or an instruction or something. I run it through an NX serving called Heath.faq, which is a Bumblebee pre-cam serving called zero-shot classification. And then I choose the prediction with the maximum score. And then you can see in my answer, I actually map each of the questions the predicted question to one of an answer, one of the pre-canned answers that I have there. You'll notice in there, I have an unrelated class. And this is one of the challenges in working with machine learning, especially large language models in production, is there are a set of questions you don't want your models to answer. There are certain things that your model, won't know, and it will still try to answer. So in this case, we're trying to account for all the things that the model shouldn't necessarily answer or wouldn't necessarily know with an unrelated class. And it works decently well in practice, but there are some issues with this approach. It's kind of difficult to capture with the zero-shot classification all of the variants of things that your customers are going to ask you. So as I said, the FAQ approach is a little bit too limited. And as everyone's seen with ChatGPT, it should be possible to answer a large set of questions with open-ended generations. And so that's the approach we took. So the next approach was to use open-ended text generation with large language models. So at the time that this initial version of Heath was written, Google had released a model called Flan T5, which is an instruction-tuned large language model with competitive performance to ChatGPT. In the paper, they presented that the XXL variant, or one of the very large variants of the model, outperformed GPT 3.5, which is the same model that ChatGPT uses under the hood on a very significant number of tasks. I had even seen at the time that some companies had been using Flan T5 as a good open source alternative to ChatGPT. And so that's the model we ended up running with. Now, this was written before Llama from Facebook came out, and everyone started going crazy over Llama and Alpaca, which is a variant of Llama as well. So we didn't have much time to benchmark with how well Llama would do versus Flan T5. But in our experience, Flan T5 is actually a very good alternative for ChatGPT. And really how this works is we pose the support task as an instruction following task with a prompt. So here you'll see the prompt we use. We give it a prompt, you are Heath, the Teller support bot, answer the following support questions about Teller. If you don't know the answer, just say you don't know, it'll try to make it up. And then we pose the question and then answer. And this kind of poses that support task as a completion task. So we fill in the question, Heath responds with his answer. The problem is that T5 based model doesn't have any knowledge about Teller. And this is a challenge that you run into when working with any large language model, is that they really don't have any knowledge about your company's specific data. And so you need a way to inject that knowledge. And the first naive approach, and this really isn't how you should do it, but this is just the approach we took initially, was to fine tune Heath on Teller specific data. In this case, Slack messages. Now, in order to just get Heath off the ground, we used kind of a naive data set curation strategy that we ended up replacing later on, as you'll see, where we took 10,000 Slack messages and we kind of grouped them together with a very naive strategy. So rather than sit there and label, we took all of the Slack messages from support conversations, and if a message was written by the same person, we would group those messages into a single message. So in this case, you can think of when you're typing on Slack or in Discord or something, and you end up sending like 5 messages in a row before someone else has a chance to respond. We would just group those into a single question, and then we would take the next message and call that the response. So in this case, Heath was getting a lot of context that was maybe not necessarily valuable to his training set, but this was just a way to build a data set very quickly. And we actually have a mixed task for this. So at the end of the talk, I'll talk about this a little bit, but all of Heath's code base is going to be open source. So you'll be able to go and see exactly how all this was built. And if you really want to play around with building on this your own, I built out a ton of mixed tasks for curating data from Slack or from your company's documentation, or using some of the data set augmentation approaches we use. So you'll be able to see how all this was implemented, how all this works, and actually deployed in your own company Slack if you'd like to as well. So this is kind of an example of what one of the instruction and response pairs would look like in our data set. So what we do is we take these, we take an instruction, hey, who are you? And then we have a response, I'm Heath, the Teller support bot. And so we end up with a data set of like 10,000 pairs of instruction and response, where the instruction is what we want to prompt Heath with, and then the response is what we want to actually have Heath output. We ran this through one fine-tuning run, and to be honest with you, it wasn't really that great. I mean, he was okay, but one of the problems was Heath overfit, essentially. So he would respond with erroneous answers from the training set, where I would ask him something and he would just make up an answer completely, or he would answer with something that he had seen in the training set because he was overfitting to what we had given him. Another problem was hallucinations, and this is something that I don't think anybody has really solved, is hallucinations with large language models. A pretty funny example of this is you would ask Heath about how much the API pricing is, and he would just make up prices like out of nowhere, which you cannot have. When interacting with customers, you obviously cannot have a large language model just making up whatever they feel like the API should be priced at that day, because that could be very, very bad. So we needed a little bit of a different approach here. So what we did instead was decided we were going to give Heath some context. So this is a pretty common thing with large language models, is you augment the knowledge of the model with context from documentation or conversations, etc. So how it works is you basically embed a set of documents or some knowledge that you want the model to have access to at inference time, and then you embed the query that someone gives. So in this case, if someone asks a question, say about the Teller transactions API or the transactions endpoint, I will have embedded that specific chunk of the Teller documentation, and at inference time, I embed my query, and then it goes out and it uses what's called a vector search to retrieve the specific portion of the documentation that is relevant to the query, and then it'll give that to the large language model that it can then use that to answer the question. So in this case, we embed company-specific info in documentation, support conversations, slab documents, etc. So anything specific to the company, store that in a XVice index, which I'll talk about XVice later on. And then at generation time, we search the XVice index and then use that retrieved info as context. This is just a high-level overview of how vector search works from Elastic. So I take images, documents, audio. In this case, it's just documents, and I turn them into a vector representation. So these large language models are really good at mathematically representing text or documents in a way that text with similar meaning have very similar vectors. So if I were to plot two sentences, on a Cartesian, plot in 2 dimensions or whatever, sentences with semantically similar meanings would be plotted close together. And you can exploit this fact with algorithms to cluster and retrieve the nearest examples to queries. In this case, the actual vector index or vector search technique we use is XVice. XVice is an Elixir library for using Facebook AI similarity search. It's a super scalable, but also super low level vector index. So if you've worked with vector index or vector search at all, you might have heard of more, I guess, out of the box battery included tools like Milvus. Pinecone is an API version of one. If you've heard of PG Vector, it's very, very similar. Vice supports the number of CPU and GPU based index types, so you can scale these indexes up to like in the order of trillions of vectors. Extremely scalable, but it also is a little bit difficult to work with if you're not familiar with how vector search works. And so we used XVice, and then we took all of the Teller API documentation, broke it into the chunks of 256 tokens. So when you're working with text, you tokenize a data set, which it essentially just means breaking up the text into smaller chunks and then converting those to integers that you can actually mathematically manipulate. We embed chunks using a similarity model. So we used a sentence transformer model, which converts the tokens that I've taken from that documentation into a vector, and then I store those in a Vice index. Another thing we did was we actually curated some support conversations. So I should say I was a little bit more patient this next training run and decided that I should probably label some data to actually give Heath some sufficient context. And so I ended up writing this pretty neat, in my opinion. I'm not a very good web designer. I'm actually a horrible web developer. Phoenix is not really my thing, but I'm very proud of this. This is my labeling live view where you can import Slack conversations and then label them for training with the instruction response pairs. So I sat there over a weekend for probably like 20 hours and labeled a few hundred instruction and response pairs with this little UI. And it was extremely mind-numbing and boring. And so I thought to myself, there has to be a faster way to do this, because there's no way I was going to be able to power through all of the 10,000 messages that I needed to step through to build a complete data set. So I decided we probably should take advantage of something called augmentation. So if you're familiar with machine learning at all, this is pretty common with image classification tasks where I can augment the size of my data set by performing small manipulations on my input data. So it's pretty common with images because if you were to say rotate an image of a cat, it's still an image of a cat, it's just rotated. So augmenting an image in this way doesn't actually fundamentally change what the class that image belongs to. We can also do it with support tasks. So there are 3 data set augmentation techniques that we use to artificially increase the size of the data set. The first one is rephrasing. So as I mentioned before with FAQs, we can kind of exploit the fact that a lot of support questions are variants of the same exact questions, just rephrased. So we can use actually the GPT-3 API to generate 2 to 3 rephrased versions of an instruction. So if somebody asks the question like, hey, how do I use the transactions endpoint? We can send that off to GPT-3 and then it'll actually rephrase the instruction to be the same question, just phrased differently. And we can artificially increase the size of Heath's data set in that way. The response remains the same because you don't want to have to, you run the risk when you're rephrasing the response in these instruction response pairs of completely losing the context and meaning of what it is you were trying to get Heath to output. But you can actually rephrase those too. Sometimes, for this, I had some examples where I would use the GPT-3 API to rephrase some of my responses to be a little bit more, I guess, friendly or support-like, because that's one of the things that GPT-3 is pretty good at. This is the prompt we actually use to send to the GPT-3 API. And this is one of the ones we used for responses. The next augmentation technique we could use is generation. So you can actually use the GPT-3 API to seed your original data set. So in this case, we automatically generate questions about the Teller documentation from or using the GPT-3 API. So I can take chunks of the documentation and I can ask GPT-3 to generate 5 instructions or 5 questions about the documentation, and then also generate the answer to that question. And this actually does like pretty well. So this is the prompt that we used to do that. It was pretty involved. It took a while to get this right because, you know, GPT-3 tends to make things up. We didn't want that to happen, especially in this case, when you're using or when you're trying to fine tune models like this, you really don't want to have a data set that's heavily augmented. I mean, a little bit of augmentation is okay, but you reach a certain point where you have so much artificial data in your data set that the quality of the fine-tuned model goes down. So we had to be a little bit careful about that, but in this case, it actually ended up working out well. And then the final kind of naive data set augmentation approach we used was what I would call groupings. So as I was going through and labeling a lot of the support questions, I realized that most questions, or not most, but there's a significant percentage of queries that people are asking that are actually multiple queries grouped into one. So you can imagine people asking questions like, okay, who are you? What is teller? In individual, or in basically a list of questions. And so we can pluck out some of the instructions that we've already labeled and group them together and create a little bit, or create an extra example that's built off of these individual queries. After all of these augmentations, I think we ended up with something like 3,000 instruction response pairs, which when you're fine tuning a large language model is probably enough. We probably could spend more time, you know, curating a little bit of a higher quality data set, but for the purposes of what we were trying to do, that worked out just fine. We did unfortunately have to use Python for the fine tuning run, which I'm not proud to admit. Unfortunately, the Flan T5 XL model we used requires a lot of memory to run on a GPU. And we just don't have the same memory efficiency tricks we needed to train this model. I think though this is kind of a validation of where you can marry up your data science team with your the Elixir engineers, where you can have your data set team do something in Python and then ship that model off to the Elixir engineers to ship out to production. We ended up training for a few hours on the Lambda Labs A100 GPU instance. It was relatively quick to go through all of these examples, and then it was relatively quick to actually implement the serving. So when we put it all together, we have a pipeline that looks something like this, where we embed queries using a smaller sentence similarity model. We search the XVice index that we built from the documentation and the support conversations that we had embedded and labeled earlier on. We retrieve the top label. In this case, that's going to be the context we inject into the model, into the large language model to do the generation. And then we generate an answer from a prompt constructed with the question and a context. And this is only about 100 lines of Elixir code. So it's pretty crazy the very complicated things you can do with Elixir and Bumblebee in a very small amount of code. And I actually have a snippet of the document or the generation serving here. So this is the actual serving, and it's does not present well on a PowerPoint slide, but you can see here there's not really a lot going on. This is how a lot of Bumblebee pipelines look. So I load a model in this case, I'm using a sentence transformers model. This is a similarity model. And then I load in the tokenizer for the same thing. I have my XVice index that I load in from a file. And then I create this. This is basically a similarity function, scores fun right here. And this is where I do the actual searching, retrieval, etc. And then I combine that with my generation serving, and then I have a pretty coherent, or pretty, I would say, exquisite or fancy language model generation. This is the actual prompt that we used to do these generations. So you can see here, I inject the context for my retrieval serving, I inject the instruction, and then I generate a response based off of the context in the instruction. And this is actually an example of Heath in production. So you can see he does very well for some very specific questions. So in this case, I'm asking him, how can I verify that webhook events were created by teller? And then Heath responds with, this is actually the correct answer. Now, one of the things you'll find with these support tasks is you want to be able to correct Heath's actions. So when you're using him, if Heath says something that's just completely wrong, you want to be able to give him feedback so you can improve him for later training runs. And so we actually built in this little correction pattern here. So in this case, I'm asking a question about how can I get item potency in the payments creation endpoint? And then Heath is responding with something that has nothing to do with the question I asked him. And so I give Heath this correction here where I say, you can use the item potency key header with unique value. Heath ends up storing that in a database that's a Postgres database, and then I have that access to that instruction and correct response pair for training later on. So some of the things we want to do with Heath in the future, or we had considered, was actually getting Heath to interact with tools. There's a paper from Facebook called Toolformer where they essentially let large language models make decisions about the tools they interact with. And then if you're familiar with ChatGPT plugins, this is pretty much the same exact thing. So can I get Heath to respond to a support query and open up a task in Linear or open up an issue in GitHub? The other thing is, can we get Heath to respond to internal queries differently than external queries? So if you have company-specific data or sensitive data that you need Heath, for example, to be able to answer when it's an internal query, when it's someone who works for the company asking, you don't want Heath to reveal that same information when it's coming from an external channel. So that's something that we had considered. How can we make that happen? And then the last one, how can we limit hallucinations? And that's something that like I said, I don't think anyone has gotten correct yet. It's really difficult to put guardrails in place for these language models to respond in a way that's guided and doesn't reveal anything sensitive about the company, or doesn't just make things up completely. And then the final thing we're really considering is Heath obsolete already? Like I said, there's a ton of companies out there building large language model based APIs that do essentially very similar things. But fortunately, the Heath framework is pretty pluggable, so you can plug in pretty much any large language model on top of it and get Heath to work. In conclusion, all of the code that was used to create Heath will be made open source, so there's going to be a repository available, and you can go ahead and access, use essentially the same code that we did in the designing of Heath, the same Slack integration, etc. And then finally, if you're interested in doing cool things with Elixir, Teller is hiring, so there's a lot of cool things with machine learning and Elixir going on at Teller. That is pretty much it. This is where you can find me. I'm on Twitter, GitHub. That's pretty much it. But yeah.
Thank you, Sean. Yeah, no, it's a fantastic talk. We appreciate it. I saw people in chat saying that they're glad this is recorded as well, because they want to go back and read through all your slides as well. And yeah, I'm seeing the applause starting. So yeah, I think we can. Oh, go ahead. Sorry.
I was going to say, I tend to talk fast, especially in the virtual environment. So I apologize if I glazed over some things.
No, I thought you did a great job. So yeah, I guess we can go to QA now. So just raise your hand if you'd like to ask a question. I believe we did that earlier in the meetup. I guess I'll go first because I do have a question myself. How did you find the current Elixir tooling for this project? It seems like you've worked with Python. What was it like, kind of as engineering perspective?
Yeah, so I would say for implementing the deployment side of things, where we had a trained model and we're just putting a simple Phoenix API together and integrating with Slack, it was essentially seamless. The only things that were challenging was actually doing the fine tuning, and that was really just because some of the limitations we have with the libraries right now. It was nothing that we can't fix, and I think I wrote probably 90% of the code is Elixir, and then there's the 10% that I'm doing fine tuning that's in Python. But I think one of the things that kind of impressed me was the workflow of going from Python to Elixir was incredibly easy because of Bumblebee. So I could just drop out a model from Python and then throw it into this Elixir app that I had already made, and then it just worked. I didn't have to do any jumping through hoops or anything like that.
Nice. Yeah, that's very interesting. The interoperability, I think that's a really great feature as well. I believe Owen, you had your hand up first, so let's go. Oh, sorry, Owen, it looks like you're muted.
Yeah.
Yes. Yeah, thanks. So, and by the way, there's a bunch of questions in the chat way ahead of me, but I was going to ask what happens with the corrections, but you already mentioned that they land in a Postgres database. So
yep, that's right.
When those corrections happen, how long does it take for those to make it into the model? Is it immediate, or is it sometime with another deploy or something, or how does that get integrated?
Yeah, so right now it would just take to some retraining. So I would have to go back and explicitly launch another training run. There was some things I'm considering doing of like dynamically updating the FICE index where as I issue a correction, it adds that, or it embeds that and then adds it to the FICE index that we're using. And then Heath has updated context, but it's definitely not instant, but that definitely could be improved.
Nice. Eric, I believe you have your hand up.
Yes, sorry. So I got the feeling, I mean, you were talking about how much things have changed since you started developing that and with what's occurred in the last few weeks. So just wondering, like, in light of what's going on today, what would you have done differently, maybe?
Yeah, I think so I designed the actual application with a very specific model in mind. I guess you could say, like, the framework that I ended up using, or the implementation I ended up using, is still pretty pluggable. But I think going into it, if I had to go back and redesign everything, I probably would design specifically with the idea that the model that we're going to end up using is going to change. I didn't anticipate that to be obsoleted as quickly as it was. It was like, I think I ended up finishing the initial training run of Heath, and then like 3 days later, GPT-4 came out, and then, or not, maybe not 3 days later, but like 3 days later, like someone released a model that was like doing basically the same thing. And then like the next week, GPT-4 came out, and then the next week, Google did Bard. And then it was like an onslaught of AI development, just like smacking me in the face. I was like a little taken aback, but I definitely probably would have been more explicit in designing a pluggable interface for, just choose your large language model and have that run here, not necessarily marrying it to the one we were fine tuning specifically.
And then just one real quick idea. You were wondering about like how to keep the documents separate, for internal versus external. So maybe you could create another index in your vector database for the internal docs, and that way you could kind of marry them and they'd be completely separate.
Yeah, actually, I think that's a good idea. Like, we had considered that. Like, I think another way was just having 2 separate models. But yeah, that is a good idea.
Cool. Just sharing a thought.
I appreciate it.
Nice. Thank you, Eric. Let's go to Jeremy.
All right. This was really great. I did have a couple questions about, such as like, have you ever heard of the semantic knowledge graph? You mentioned Elasticsearch.
I have not. No, I'm looking at the PDF. I saw that note there. I have not heard of it. No.
It was originally made for Solar, which is one of the competitors for Elasticsearch, and it converts 2D data into graph data. But have you thought about recording down similarity scores when you are writing data for the corrections to the database? And have you checked out hostile examples or people people who are trying to mess up your model on purpose? If you have no barrier between internal and external, it's possible that external people could correct your model to incorrect things.
Yeah, so right now Heath is just deployed internally. It's kind of like we're going through like I guess a trial period, because like I said, there's a lot of things that Heath does that you don't necessarily want customers to see. So that's definitely something we're considering, and there's still a lot of work that needs to be done before Heath is ready for prime time. And then there is like I said, there's always the thought that is it worth building something like this out and investing so much in it if there's APIs out there that do essentially the same thing. So it is a trade-off.
And then the last question I had is, have you ever thought about adding something that would give you a breakdown of where that answer is coming from? It's just math underneath the hood, right? And something that would tell you what it factors into, and what topics or whatever else factor into it, or where is it looking, or where is it coming from, the answer?
Yeah, no, that's a good point too. I think in the literature, they're called like look back citations or something like that. So there's a model from Facebook that they released a few months ago. It was a open source science model where it could actually generate citations. And I think GPT-3 can actually do this as well, or maybe it's not GPT-3. But there are models out there that can dynamically generate citations. And it's something we looked into. Something I've thought about considerably is, can we come up with the context that, you know, Heath actually used to generate this answer, and improve the generations in that way. I think for this case, or for this initial version, we kind of just fell off, but yeah, it's definitely something worth considering.
Perfect, thank you.
Mhm.
Nice. Andy, you want to go?
Yeah, I had questions about the model generation. So it looked like you had used some service like Lambda service with like a beefy GPU to generate the model. What was the cost of that, and what is the output of that? Like, how big is the model, and does that just run? How is that running on the server?
Yeah, that's a good question. I think for the initial training run, so altogether, I probably spent less than $10 on Lambda Labs. So it wasn't really a large data set. It probably would have been a little bit more expensive had we ended up choosing the XXL variant. So there is a larger variant of the Flan model that's significantly better than the one we ended up running on. And in the future, it might be worth considering that. But it ended up being pretty cheap just because the amount of training time we had was pretty low. And Lambda Labs, the GPU hours are pretty cheap as well. I think it was like 80 cents per hour or something like that. So it's not very expensive. The actual deployment of Heath I would do a demo, but I'm in the middle of renovating my office. And so the computer had Heath deployed on is unplugged right now because I've been moving some things around. But he is literally just deployed on one of the computers I have here. It's not using a GPU or anything like that. And I think the generations take somewhere between 15 and 30 seconds. So it's still pretty quick. And it's practical to run on something relatively small. Yeah.
Thanks.
Mhm.
Nice. Saji, you want to go?
Yeah, sure. Given all of the large language models kind of, propensity to hallucinate and stuff like that, I'm sure there's been a lot of thought into how to deal with that and handle that. And I was wondering if you could share kind of the different approaches and ways people are thinking about that, and if you have a specific approach that you lean towards.
Yeah, so the retrieval, like the retrieval augmentation is probably the top way to get the models to stop hallucinating. So like the example I give about API pricing is, I would say, pretty easily solved by just giving the model access to the API pricing at generation time. And so that's probably the most well known, but you do kind of run the risk there of you're still at the mercy of a large language model, in terms of doing the actual like similarity search and retrieval. Some of the other things we looked at was there's a paper from Anthropic AI called Conversational AI, or reinforcement learning from AI feedback or something. And I think Anthropic shows in the paper that it does this constitutional approach. You essentially define a constitution for your model to follow. So you give it a set of rules, and then during the training process, or I think it's like during the data set generation process, you have an AI model critique outputs based on the set of rules that you defined for it. So if one of your set of rules is, don't make up answers, respond with I don't know, then I think I'm relatively confident that would help guide the model away from making things up. Because one of the problems is the models, they don't know when to say I don't know. They just want to come up with something that completes your sentence. But yeah, those are really the two that I looked in the most. Unfortunately, like I said, there's really nothing concrete that can actually stop the models from just making things up. Possibly one of the things I'd seen as well that might help with getting it to, not output, sensitive information, or not output something that's inappropriate, would be to just do something like the Stable Diffusion model does, which is they have a what's called what is it called? It's basically a classifier that runs on the generated output to see if the generated output is NSFW. So having an additional smaller language model that just sits there and looks at the output text from Heath and says, okay, is this something that is sensitive or inappropriate, or something that would be damaging to the company? So that's probably another I would say, relatively simple approach. Just having a classifier that classifies whether or not an answer should be a refusal. And I wouldn't be surprised, honestly, if that's similar to what if you've interacted with the Bing chat, Sydney. I wouldn't be surprised if they have something similar working. And yeah.
Nice. Eric, I see your hand up.
Yeah, so just a follow-on question. You'd mentioned that there were some competitive services that you could just pay for. Which ones did you look at? Which ones did you like? Why did you like them? What are the pros and cons?
Yeah, I think it's Intercom, maybe. I don't know if that's the right Intercom, I think is the one support company, but they recently released it's literally a Slack bot that lives in your Slack and responds to questions. I think Anthropic has a Slack integration as well. Anthropic AI is one of the competitors to OpenAI. Their model is behind a wait list right now, so it's a little bit difficult to access. I haven't actually benchmarked any of them, so I'm not really sure which ones would be the best. I would assume Intercom is probably competitive. One of the things that it becomes a serious, I would say, like competitive advantage in this space is having access to data, right? That's kind of the bread and butter. And I would say Intercom having access to a lot of support conversations, because I think they are a support management service. Someone can correct me if I'm wrong, but I would say they probably have, the gold standard of support data to train a model on. But I haven't really checked any of them out explicitly.
Nice. Yeah, a company I worked for used Intercom as well. It seems like they do have a ton of data. Okay, Jeremy, your hand's up. Oh,
Yeah, I forgot to hit the unmute button. Thank you. Have you tried implementing a threshold where if you have an answer generated or all answers generated under a certain threshold that it just says, I don't know more about that. Your question seems to be around these topics. Provide more info? If so,
Yeah,
how did
I think that's another thing. Yeah, no, so I didn't try anything like that, but I think that's another thing that would work pretty well. Having something like a score or something like, okay, this generation is not good, and so let's just refuse. With Heath kind of being in testing, we kind of want to see, what he generates to a variety of questions. I think one of the other things too is with him not being widely deployed, it's hard to cover the surface area of all the possible attacks, I guess, that you could use to exploit a large language model. I think that's something OpenAI obviously has seen with all of the prompt injection and some of the crazy things that you can get the models out. But
nice. Kevin?
Yeah, I was wondering, so you have a lot of experience now with the Python space and the Elixir space. Are there things about Elixir or Python that are more like inherently lending themselves to the machine learning thing? And is one better for training? One is better for actually running the trained models. What could you summarize your experience there? And, as an Elixir person that's looking to get into, as like a follow-up question, as an Elixir person looking to get into the space, is it still advisable to just go learn what's already happening in Python as like a point of reference?
yeah, so the first question on is there things that are easier to do in Python? I think it's easier in Python for me to slap together like a horrible but quick solution to a problem. Like I'm not a great Python developer, but I am a pretty good, I would say, like Jupyter Notebook hacker, and I can just make something that works. And so at times I think prototyping might be a little bit easier, which has some advantages, especially when you're putting together like training pipelines. But when it comes to actually designing a production grade, solution, I think Elixir obviously is a significantly better choice. In terms of would I choose Python, or is it worth just learning things in Python? I think obviously you can't beat the amount of material that's out there that's written in Python, and so taking some time to learn enough Python to get to interact with a lot of the training material for machine learning that's out there, it couldn't hurt. I actually do. Is this still? Are we still recording right now?
Yeah, we can stop recording if you want.
Yeah, sure. Well, I'll talk about it after the recording, but I don't want to like have it, leak anything right now while it's recording, but I'm okay with it being in a small group setting. Yeah, I think it wouldn't hurt to learn Python for that reason, or at least learn enough Python. And I think someone in the chat had ChatGPT write your Python. Yeah. Yeah, that's what I would say.
Okay, as one more follow-up question here, is anybody working on being able to kind of like have Elixir and Python work together better, so that you could essentially go grab some Python code and have Elixir, run it and supervise it, etc., and like cooperate with it more easily?
Orchestrated. Yeah, I think I'm not 100% familiar with that. There are ports. There's a Python port I think I remember seeing when we were going through and actually like building out the NX and EXLA ecosystem. It was it was a decision between, are we just going to bind ourselves to TensorFlow or some other library, or we can actually build things from the ground up. And we ended up building things from the ground up, so it took us a little bit longer to get off our feet to develop out a mature ecosystem. But I think in the end, it helps us move a little bit quicker. But I'm not really familiar with the problem set of people using Elixir to orchestrate Python.
Nice. Owen, you got a question?
Yes. So I fully intend to read this book at some point, Genetic Algorithms in Elixir. Until then, if I wanted to play around, say with Hugging Face, Livebook and everything, how do you go about, like, I've glanced at the Hugging Face and I get lost immediately in the sheer volume of models. Like, how do you know, like, where do you start if, say, you're trying to build a customer support bot? Like, how do you know which models to be kind of looking at?
To use? Yeah, so I mean, it's really difficult to stay on top of what the state of the art is, what models people are using. Honestly, Twitter is like my best machine learning friend, because I get all of my machine learning updates from Twitter. There's a ton of people to follow that they release, like, this is the new state of the art model, this is the new API to use, this is the new whatever. So that's where I get most of my news in terms of machine learning. Hugging Face does have a really good open source book. Like it's like a machine learning book. It takes you through how to use the transformers library specifically. It's been a while since I've looked at it, so I'm not sure how up to date it is, but with how much they are investing in the open source machine learning ecosystem, I would be surprised if it was out of date. They're spending a ton of time on those training materials. Other than that, in terms of like what the best models to use, or how to find the best models to use, or the best techniques to use, I'm a big fan of just looking at some of the open source projects that are out there that are using models under the hood and seeing how they're doing it. I would say like Hugging Face Spaces actually is a pretty good place to look. They have a ton of spaces that demonstrate how to do certain tasks, and then they actually have next to the space the implementation, and so going straight to the source code based on that implementation is pretty valuable.
And last question, has Heath fallen in love or tried to escape the machine?
That is he has not, but he definitely has some very strange behaviors. He just makes things up and says what he wants. It's hard not to laugh at some of the things that he ends up generating.
Awesome. Thank you again, Sean, for the really excellent talk. I'm gonna stop the recording now.